Hello and welcome to another episode of You Were Absent from My Class. So today, guys, is Monday the 31st. Wanted to keep you guys caught up on what we're doing because it's pretty simple, but yeah, just want to keep you caught up. So first thing we started out with, guys, is just review. So again, we really want to get this base understanding of using these element cards to basically explain what the atom is or what it looks like, what it's made of. Okay, so again, up here, the smaller number, right, we refer to as the atomic number, and that atomic number tells us how many protons we have, right? And so that one's pretty easy. When it asks you how many protons there are, we just can say, okay, that's our atomic number. Okay. Now, this one, it's still kind of tripping people up, but it's very, very simple, guys. So the atomic mass, we know the mass is the number of protons and neutrons. Okay. So we know we have a total of 19 protons and neutrons, okay, that make up the nucleus. Of those 19, we know 9 of them are protons. Okay, so then it becomes very simple when we say how many neutrons are. Well, we have 19 protons and neutrons. 9 of those are protons. So that leaves only 10 can be neutrons. Okay, so we can look at that and we can write that out and we can say, okay, 19 minus 9, or our atomic mass minus our atomic number, is going to give us the number of neutrons, and in this case it's 10. Okay, so that one's really simple, guys. Like if we can just get that idea and understand that this is just saying how many of these do we have total, right? We got the mass is made up from the protons and neutrons, and we know how many protons we have. So we just got to do a little quick math to figure out number of neutrons. Now, electrons still a little bit trickier, but basically we don't see any sort of charge up here, right? We don't see a +1 or a -1, and so that tells us that this atom is neutral. Now, one thing that a lot of people do is they say, "Oh, it's neutral. That means there's 0 electrons." Well, that's not true. When we hear the word charge, we know that protons have a positive charge. Okay, these are positively charged, and electrons have a negative charge. Okay, so when we say neutral, we're saying we have the same number of positively charged protons as we do electrons. So then it becomes really easy, right? So if this is neutral, we know we have 9 protons, and to cancel out those 9 positive charges, we need 9 electrons. Okay, and then when that becomes unbalanced from gaining or losing electrons, that's where we see a charge. But this one's neutral, so we should have ended up with 9 protons, 10 neutrons, and 9 electrons. Okay, now this is where things get a little wild. We talked about, okay, yeah, the periodic table is just telling us different types of atoms, and as we know, we start with hydrogen up in the top left. It's got 1 proton, and then they get bigger and bigger and bigger and bigger. So we started to think about, okay, well, how are these atoms created? They didn't come out of nowhere. What's a logical way that they be created? Well, they're kind of like building blocks. So if you start with the smallest atoms and start fusing them together, um, we can get bigger ones. Now, that's the really simplified version. It takes immense heat and pressure for this to be able to actually take place. And we find out where that actually happens is in stars, right? And so that's where we're really starting today is, okay, when is hydrogen and helium fusing together? When do we see that? When do we see these heavier elements? And so we're starting to get this idea of when this is taking place. Okay, but before we do that, we had 2 words, our key words were nucleosynthesis. So really, we can break that down to nucleus formation. So we are going to make the nucleus of atoms. And how we do that, let's add this to our notes as well. I'll pause the video and write these down. But nucleosynthesis is just the formation of heavier elements using lighter elements by nuclear fusion. So we're fusing the nucleus, same thing, nucleus fusion, or sticking it together, and this happens in stars. And the type of element that's formed just depends on the type of star that it is and where it is in its life cycle. Okay, and that's kind of where we're going to begin this week and look at. okay, how do we progress and start from just hydrogen and get to these heavier elements like iron, and then beyond iron into, our leads and our golds and things like that. Okay. So then nuclear fusion is just a little bit more specific of a process where we're fusing together these specific nuclei. And that's really what releases a lot of energy. So we think of our sun is a star, and it gives us a lot of energy. That nuclear fusion powers um, that happening. So that provides the energy. And we're just adding protons and neutrons into a nucleus, okay, until we get bigger ones. Again, make sure you have this written down in our notes. That's really important. So we can kind of see this here, right? So as we start out with a small, light little element like hydrogen, and we crash it into another hydrogen, and then we get a neutron, and we start crashing things together, we start to develop these bigger atoms. And then we get bigger and bigger as we go. Okay, so we're starting with the smallest ones and working to the largest. Okay. Um, So then what we did is we got these two handouts, and I'll show you what they look like. We'll make sure you get these when you get back. Um, is we started with this, okay? This kind of breaks down what we just talked about, nucleosynthesis and nuclear fusion, and kind of where these are taking place. But we had people start out by reading this. So if you want to, pause the video, read over this real quick. But basically, what it says is most of a star's life, it's going to take hydrogen and turn it into helium in their core. And we got that hydrogen from the Big Bang, right? So this idea of the Big Bang is where we get all this matter cast out into the universe. It begins to come back together. We start this fusion process, and we're primarily fusing hydrogen, turning it into helium. But then, as we run out of hydrogen, uh, the star begins to die, and it starts to turn into what we know as a giant star. And then we're going to start to fuse helium until it can't do that anymore. Bigger stars, they go a little beyond that, right? So they can fuse heavier elements together because there's more pressure, more heat, and we can get all the way up to um, iron in this process right before a star dies. And then finally, the last, and iron's only element 26 of 128 or 118. And so where do we get these really, really heavy ones? Well, so when we get this big massive star and it finally collapses, we get these heavier, we have enough neutrons, we get these heavier elements beyond iron. Okay, so that's kind of what this says. So this really just kind of lays it out. Okay, so we can see smaller stars. They're going to go through this process, and basically for all their life, they're fusing hydrogen into helium. Okay. But when they run out, we can see that helium begins to fuse and form things like carbon and oxygen. That's in just a normal red giant star. But in a supergiant and a lot bigger star, this continues, and then we start to fuse heavier atoms beyond carbon, but not anything heavier than iron. So we get up to iron, and then finally, when we get to supernovas, where we see these heavier elements, and that supernova explodes and sends those heavy atoms or heavy elements out into the universe, where they can then make planets. Okay, so kind of a visual of this. One thing that we talked about is this kind of the two main pathways for a star. So we start out at this nebula. So this is what happened after the Big Bang. And they start to come together, form a star. That star turns into a red giant, planetary nebula, white dwarf. Bigger amounts of mass, right, are going to form bigger stars, massive stars. And then they go super red giant, finally supernova. So this is where we see the really heavy elements being formed. So that's kind of where we left off for today. Tomorrow we're going to watch some videos that really start to clarify that. So what we did is with this handout, we're going to take this and we're going to color coordinate it. So we know that smaller stars, so this, say we're going to color this yellow. Ooh, I even got pens. We're going to color coordinate it to where we say, okay, this is yellow, and we know that the two atoms involved here are hydrogen and helium. Okay, then let's do something that we can actually see. After that star begins to die, we're fusing helium, we start to see elements basically from lithium through oxygen. Wow, that's sloppy, being formed. If we have enough mass and we have a massive star, then we get these, okay, all the way up to iron, And then finally supernova is everything else. So that's kind of what they did there. So anyway, so that's where we're at for today. We're going to continue to work on this on Wednesday and Thursdays, where we're going to begin our project, which basically breaks this down. Okay, so we want to see this take place, and we're going to add some pictures, things like that. That's what we're going to do for our project. So hopefully this helps. See you guys. Bye.